Interference detection is a valuable tool for detecting design errors in assemblies that don't have moving parts. However, if your assembly has moving parts, collision detection is the tool that will help you make sure your mechanism is free of design flaws. In this example, I'll be using collision detection to make sure the swing arm doesn't hit this web as it rotates. If I click the Move Component tool, it will allow me to rotate the arm. But if you look more closely here in the Property Manager, you'll see collision detection is one of the options available when using the Move Component tool. Before I activate collision detection, notice that the arm is free to swing. And it's difficult to tell if there's a problem with the web. When collision detection is turned on, several other options become available. The first option allows me to specify whether I want to analyze all of the components in the assembly or select just a few. In order to make collision detection efficient, my advice is that you only analyze components that are affected by the movement. Here, for example, it's clear that the base plate will not be affected by the arm, so I can focus on just the arm and the bracket. Once the components are selected, I have to click Resume Drag to continue with the analysis. As I rotate the arm, if collisions do occur, this checkbox allows me to specify whether I want the arm to stop when it collides, or if I want it to continue moving through the part. Either way, it will be obvious if a collision occurs because of these settings down here. If I do have a collision, I want the colliding faces to highlight, and I want to hear a sound as the collision takes place. Now I'm ready to rotate the arm. As I move past the web, you can clearly see the faces highlight. It's clear I have a problem here.